Something is moving beneath the ice, not on the surface, not in the thin, airless sky above it, but underneath, hidden below a crust so cold, so fractured, and so alien that for decades, scientists could only guess what was happening there. Europa should have been simple: a frozen moon orbiting Jupiter, a bright cracked sphere locked in the outer solar system, too far from the sun to be warm, too small to be active, too distant to matter the way Earth matters. But Europa refused to behave like a dead world. The first close images showed a surface unlike anything scientists expected. It was smooth in some places, broken in others, and almost completely missing the ancient scars that should cover a moon this old. There were long dark lines stretching across the ice, like wounds. There were ridges, bands, chaotic blocks, and strange reddish-brown stains marking fractures across the surface. It looked less like a frozen corpse and more like a world under pressure. And the deeper scientists studied Europa, the more disturbing the evidence became, because those cracks were not random. They were signs something beneath Europa's ice was pulling, shifting, pushing upward, and possibly breaking through. For years, that something remained hidden. But today, after decades of spacecraft data, magnetic measurements, surface analysis, and new mission planning, the picture is becoming clearer. Europa may be hiding one of the largest oceans in the solar system beneath its frozen shell, a global ocean of salty liquid water wrapped around the entire moon, locked away from sunlight, and possibly touching a rocky seafloor deep below. NASA's Europa Clipper mission, launched on October 14, 2024, was built to investigate exactly that question: whether places below Europa's icy surface could support life, using 49 close flybys after it reaches Jupiter in 2030. And that is what makes Europa so strange. It is not the ice we see that matters most, it is what the ice is hiding. Europa is one of Jupiter's 4 large Galilean moons, discovered in 1610. From Earth, it appears as a small point of light near the largest planet in the solar system, but up close, Europa becomes something far more unsettling. Its surface is mostly water ice. That part is not unusual for the outer solar system. Many moons are icy, many are frozen. But Europa's ice is different because it appears young, broken, and repeatedly disturbed. If a world is geologically dead, its surface usually tells the story. Impact craters accumulate over time. Ancient scars remain visible for billions of years. The moon is covered in them. Callisto, another of Jupiter's moons, is heavily cratered, preserving a long record of impacts. Europa does not look like that. Its surface has relatively few large craters, which suggests that it has been resurfaced over time. Something has erased or disrupted older terrain, something has refreshed the crust. That alone was enough to raise questions, but the cracks made it worse. Europa's surface is crossed by long lineae, dark streaks and ridges that can stretch for hundreds or even thousands of kilometers. Some appear as double ridges with raised edges and a central trough. Others look like bands where the crust has pulled apart and new material filled the gap. Some regions are chaotic, with broken plates of ice seemingly shifted, rotated, and frozen again in new positions. These are not the marks of a simple frozen world. They look like tectonics, not plate tectonics like Earth's, where rocky plates move over a hot mantle. Europa's version would be ice tectonics, the movement, cracking, and recycling of a frozen shell above something softer, warmer, or liquid beneath. And if the ice shell is moving, then Europa is not just frozen, it is active. The strongest clue came from magnetism. NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003, made repeated flybys of Europa. It measured how Europa interacted with Jupiter's powerful magnetic field. The result was one of the most important discoveries in planetary science. Europa appeared to generate an induced magnetic field. That does not mean Europa has a magnetic field like Earth's, created by a molten metallic core. Instead, it means Jupiter's changing magnetic environment was inducing electrical currents inside Europa. For that to happen, Europa needed a conductive layer beneath the surface. The most likely explanation: salty liquid water, a global ocean. This changed Europa from an icy moon into an ocean world. The idea was staggering. Beneath the bright fractured crust, there might be an ocean tens to over 100 kilometers deep. Some estimates suggest Europa could contain more liquid water than all of Earth's oceans combined. Not on the surface, where sunlight reaches, not under a blue sky, but buried in darkness, under kilometers of ice, heated not by the sun, but by gravity. This is where Europa becomes dangerous to our assumptions. Because for most of history, humans imagined life as something tied to sunlight. Plants use sunlight. Food chains depend on sunlight. Warmth comes from the sun, but Earth itself showed us that life can survive in darkness. At the bottom of Earth's oceans, hydrothermal vents release heat and chemicals from the seafloor. Entire ecosystems exist there without sunlight, powered by chemical energy. Microbes use compounds from the vents, and larger organisms depend on those microbes. So when scientists looked at Europa, they began asking a serious question. If Europa has a salty ocean, if that ocean touches rock, if tidal heating provides energy, could chemical reactions occur there? Could Europa have the ingredients for habitability, not proof of life, not evidence of life, but the conditions that make life possible? That is why Europa became one of the most important worlds in the solar system. But an ocean alone is not enough. For Europa to be truly interesting, there must be a way to exchange material. The surface receives radiation from Jupiter. Chemicals are altered there. The ocean below may interact with rock. If these environments remain separated forever, chemistry is limited. But if material from the surface can move downward and ocean material can rise upward, Europa becomes much more complex. That is where the ice shell matters. Scientists do not yet know exactly how thick Europa's ice is. It could be several kilometers thick, or much thicker in some regions. It may be rigid in some places and warmer or more mobile in others. Some models suggest shallow pockets of briny liquid might exist within the ice shell itself, separate from the deep ocean. These possibilities are not random speculation. They come from the features on Europa's surface. The chaotic terrains look like places where the ice shell may have been disrupted from below. Blocks of crust appear to have broken apart and moved within softer material before freezing again. Some ridges may form when cracks open and close repeatedly under tidal stress. Some dark bands may represent regions where the surface spread apart. Europa is being pulled by Jupiter's gravity, and that pull changes as it orbits. The Moon is slightly stretched and squeezed again and again. This tidal flexing generates heat inside Europa, helping keep its ocean liquid and stressing the ice above it. The ice is not just sitting there, it is being worked, bent, cracked, repaired, broken again, and somewhere in that process, material may be moving between the surface and the hidden ocean. NASA describes one of Europa Clipper's key goals as measuring the ice shell's thickness, analyzing its structure, and looking for warmer regions where liquid water may be near the surface or may have erupted onto it. That mission goal exists because the ice is the doorway. If Europa's secrets are below, the shell is where they leave fingerprints. One of the most haunting possibilities is that Europa may have plumes. Water vapor plumes have been observed clearly at Enceladus, Saturn's moon, where geysers spray material from a subsurface ocean into space. Europa's plume evidence is more uncertain. Some observations have suggested possible water vapor activity, but it has not been confirmed with the same confidence as Enceladus. Still, the possibility matters enormously. If Europa sometimes ejects water vapor into space, then a spacecraft may be able to sample material from beneath the ice without landing or drilling. That would be one of the most important opportunities in astrobiology. Imagine an ocean sealed beneath an icy crust for billions of years, and then imagine that some of its material escapes into space in brief, fragile bursts. That would turn Europa from a hidden world into a world that sometimes leaks its interior. Even without confirmed plumes, Europa's surface may already contain clues. Materials from below could be exposed along cracks, ridges, and disrupted regions. Dark reddish-brown stains may include salts or compounds altered by radiation. The exact chemistry remains debated, but it is clear that Europa's surface is not pure, clean ice. It is chemically processed. Jupiter's radiation bombards the surface constantly. Charged particles slam into the ice, breaking molecules apart and creating oxidants. If those oxidants are transported into the ocean, they could provide chemical energy. That possibility is extraordinary, because it means Europa's dangerous radiation environment might actually help produce useful chemistry for life below. The same radiation that makes the surface hostile could help create ingredients that matter beneath the ice. Potentially habitable below, frozen outside, liquid within, dark but chemically alive. The surface of Europa is one of the most radiation-blasted environments in the solar system. Jupiter's magnetic field is enormous and powerful. It traps high-energy charged particles, creating harsh radiation belts. Europa orbits inside this dangerous region. Any spacecraft passing close must be protected. Any future lander would face severe radiation exposure. Human exploration there would be extraordinarily difficult, but the radiation does not penetrate deeply into the ice. Below the surface, Europa may be shielded. A few meters of ice could protect material from the worst radiation effects. Deeper still, the ocean would be isolated from the surface's most hostile conditions. This creates a strange, layered world. The top is chemically altered and dangerous. The middle may be fractured, moving, and possibly filled with briny pockets. The deep interior may hold a dark ocean, and the seafloor, if the ocean reaches rock, may be where the most important chemistry happens. That is the real hidden question beneath Europa's ice. Not simply, is there water? The real question is, what is happening where the water meets rock? On Earth, water-rock interaction can produce chemical gradients. It can release hydrogen. It can support microbial ecosystems. If Europa has hydrothermal activity on its sea floor, then its ocean may have energy sources independent of sunlight. This is why Europa is not just another icy moon. It may be a complete environment. Ocean, chemistry, energy, time. The ingredients do not prove life exists, but they make Europa impossible to ignore. And yet, Europa is not easy to understand. Every answer produces another uncertainty. How thick is the ice? How salty is the ocean? Does the ocean touch the rocky mantle? Is there active seafloor chemistry? Do surface oxidants reach the water below? Are there plumes? Are there shallow lakes within the ice shell? Is the ice recycling material over time? These are not small details. They determine whether Europa is merely an ocean world or a potentially habitable one. The upcoming Europa Clipper mission is not designed to detect life directly. That distinction matters. It will not arrive with a microscope looking for organisms. Its goal is to determine whether Europa has conditions suitable to support life, investigating the moon's ice shell, ocean, composition, geology, and possible current activity through repeated flybys. That is the correct scientific approach. Before asking whether life exists, we must first ask whether the environment could support it. Europa is the question before the question. A world that may not show us biology but could show us whether biology is possible beyond Earth. One of the strangest features on Europa's surface is chaos terrain. These regions look as if the crust has been shattered into blocks, moved around, and frozen again. Some blocks appear like broken rafts, embedded in a darker, rougher matrix. The pattern resembles sea ice on Earth, where ice plates crack and shift over liquid water. But Europa is not Earth. There is no open ocean on the surface. No waves breaking through daylight, no atmosphere thick enough to drive familiar weather. Everything must happen through ice, tidal stress, heat, and internal movement. Some models suggest chaos terrain could form above shallow subsurface water pockets. Warm material rises from below, destabilizes the ice, breaks the surface into blocks, then refreezes. Other models suggest the process may involve convection within the ice shell or deeper ocean interactions. Whatever the exact mechanism, chaos terrain suggests movement, and movement suggests exchange. That is why scientists focus so intensely on these regions. They may be among the best places to search for material that came from below. If ocean chemistry has reached the surface anywhere, chaos terrain, ridges, and disrupted bands are among the places where it might be exposed. Europa's surface is not a blank shell. It is a coded message. Every crack, ridge, band, stain, and broken plane is a clue to what the hidden ocean is doing. The problem is that we are still learning how to read it. There is another reason Europa feels so strange. It is close to the most powerful planet in the solar system. Jupiter does not simply hold Europa in orbit, it dominates it. The planet's gravity stretches Europa, while gravitational interactions with Io and Ganymede help maintain Europa's orbital eccentricity. That eccentricity is critical. If Europa's orbit were perfectly circular, tidal flexing would be weaker, the internal heating would be different, the ocean might not be maintained in the same way. So Europa's hidden ocean is not only a feature of the Moon itself, it is a product of a larger system. Jupiter provides the gravitational force. Neighboring moons help maintain the orbital pattern. The interior flexes, heat is generated, ice cracks. The ocean persists. Europa is not isolated. It is part of a machine, a gravitational engine built around Jupiter, and that machine may be keeping a buried ocean alive. This is one of the most profound discoveries in modern planetary science. Habitability does not always require a planet near a warm star. It may exist around moons, powered by tidal forces, hidden beneath ice, far from sunlight. That idea changes everything. It means that the search for habitable environments cannot be limited to Earth-like planets. It must include ocean worlds, moons, frozen bodies, places where the surface looks dead, but the interior may not be. Europa's hidden ocean also forces a philosophical shift. On Earth, the ocean is visible. It defines our planet. It reflects sunlight, shapes weather, and covers most of the surface. On Europa, the ocean is invisible. It is locked away. If life exists there, it may have never seen a sunrise. It may have evolved in darkness, under crushing pressure, cut off from the universe above. That possibility is both thrilling and unsettling, because it suggests life, if it exists elsewhere, may not look for the same things we look for. It may not need open skies. It may not need continents. It may not need sunlight. It may need only chemistry, stability, energy, and time. Europa may have had all of those for billions of years, but again, we do not know. And that uncertainty is what makes the moon so powerful as a scientific target. It sits at the edge between possibility and evidence. We have not found life there. We have not sampled its ocean. We have not drilled through its ice, but the signs are strong enough that we cannot ignore it. The moon is telling us something is beneath the surface. And now, for the first time, humanity has sent a mission built specifically to listen more carefully. When Europa Clipper reaches Jupiter in 2030, it will not orbit Europa directly. The radiation environment is too harsh for that. Instead, it will orbit Jupiter and perform repeated close flybys of Europa, gathering data during each pass. NASA states the spacecraft will conduct 49 close flybys, using instruments to study the ice shell, surface, ocean, composition, and potential activity. This strategy matters. Each flyby will reveal part of the moon. Radar may probe the ice. Magnetometers may refine the ocean evidence. Cameras may capture surface features in unprecedented detail. Spectrometers may identify chemicals on the surface. Thermal instruments may look for warmer regions. Dust and particle instruments may analyze material around the moon. Europa Clipper is not going there to answer one question. It is going there because Europa is a system of questions, and the most important one remains hidden beneath the ice. What is down there? A sterile ocean? A chemically rich ocean? A world with hydrothermal activity? A place where surface and ocean exchange material? Or something stranger than our models can currently imagine? That is the danger and beauty of Europa. It is close enough to study, but still beyond reach. Familiar enough to compare to Earth, but alien enough to challenge everything. Something strange is hidden beneath Europa's ice. That statement is not exaggeration. It is the logical conclusion of decades of evidence. A young, fractured surface, an induced magnetic field, possible ocean chemistry, tidal heating, strange terrain, possible plumes, a moon too active to be dead, too complex to be dismissed, and too promising to ignore. Europa does not reveal itself with volcanoes like Io. It does not show liquid seas on the surface like Titan. It does not spray confirmed geysers as dramatically as Enceladus. Its mystery is quieter, locked under ice, written in cracks, measured in magnetic signals, inferred through gravity, chemistry, and motion. And maybe that is why Europa feels so haunting, because it reminds us that the most important worlds may not announce themselves loudly. Some hide, some wait. Some keep their oceans beneath frozen shells for billions of years, while the universe passes silently above them. And if Europa truly has a habitable ocean beneath its ice, then the meaning of the solar system changes. Earth would no longer be the only obvious place where nature found the right ingredients. It would be one example, one version, one surface ocean under sunlight, while far away, around Jupiter, another ocean turns in darkness, sealed beneath ice, warmed by gravity, and possibly carrying chemistry we have never seen. That is what makes Europa one of the most important worlds ever discovered. Not because we know what is beneath the ice, but because we finally know enough to understand that something is there, something hidden, something vast, something that may force us to rethink where life can exist. And perhaps, when Europa Clipper finally arrives, the greatest discovery will not be that Europa is like Earth, it will be that it never needed to be.